Welcome, everybody, to another edition of Amplify Your Business. Today, I'm going to be talking to Ed MacNab. He's the CEO of 3D Printed Homes Corporation, or commonly referred to as 3D PHC. Welcome to the show, Ed.
Oh, thank you. It's a pleasure and an honor to be here.
Well, so one of the things that I'd love to get into is the backstory of how you developed this company, because I find it just absolutely fascinating. So you're actually printing homes out of concrete as if it's like a giant inkjet printer or something like that. And so I would just love to hear a little bit about the technology, what you have as a company, and then get into the backstory of entrepreneurship and how you found yourself as a founding member of this great company that you have going on down in Calgary.
Okay, so full disclosure, I have to correct something. You said that we are printing houses, and that's not quite true yet.
Okay.
We will print houses, and we'll print them out of concrete, and we'll print them quickly and inexpensively. We do expect to go live or go commercial, possibly as soon as Q2 of this year. We're still looking for an early stage investor, but that is the objective.
Excellent.
So many of your listeners will be familiar with desktop 3D printing or home hobby 3D printing, where a little cubicle, a little desktop sized machine squirts out plastic and builds up things layer by layer. And it's commonly used for coffee cups and key fobs and baby Mandalorians or whatever the knickknack of the day happens to be.
Yep.
So some people in Europe a few years ago looked at that and went, well, what if we made it way bigger? And instead of squirting melted plastic out, we squirted quick setting concrete. If we did that, could we print a house? And it turns out that yes, they can. And so this technology has been developing for 5 or 6 years now in Europe, and they're building houses in Germany and Holland, pardon me, the Netherlands. We don't call it Holland anymore. Spain, Belarus, of all places, down into Italy, and then over into the Middle East. Dubai has a published mandate that 25% of all new construction in Dubai will be 3D printed within the next 5 years. There are a couple of companies in the US that are 2 or 3 years ahead of Canada, and they are printing a few houses. Now, they're in the 20 or 30 houses in the whole of the US. Canada has approximately none at this point. There is one test house printed, and it's over on a lake near Nelson, BC. And it's cool, but commercially available rental accommodations or houses for purchase have not yet been built in Canada.
Okay,
we had always, go ahead.
Yeah, I was just going to say, so why do you think that is? Why are we behind, I guess, what's happening over in Europe and other parts of the world?
I think part of it is Canadians are inherently cautious with the adoption of really bleeding edge technology. And this was up until very recently. It's still leading edge, but no longer bleeding, no longer the true cutting edge. The machines to do this, because of their size and complexity, are quite expensive. The least expensive one commercially available is around $250,000, and they run up into their $1.5 to $2 million range, depending on how big you want to go and what sort of projects you have ongoing. So there's some very real risk for a startup with no jobs to do and needing $1 million piece of equipment. So it's challenging to raise that kind of seed money in Canada. Canada also has one of the most bizarre climates around for trying to work in concrete. It's not uncommon to see plus 40 degrees in the interior of BC, in the Okanagan. It's not uncommon to see minus 40 and colder in Edmonton, where you are, occasionally in Calgary. And concrete, working with concrete in that wide range of temperatures can be quite a challenge. So there's been a lot of research at multiple universities around the world on adjusting the chemistry of concrete in order to make it usable in a wide variety of climatic conditions.
And so do you feel that technology is here now then? It's something that can be achieved in that wide variety of climate situations?
Absolutely. Now, we're still not going to be printing outdoors in January in Edmonton. The conditions are just, you can't print, there's water in concrete and it freezes. You can't use it. But we can put up tents over job sites. There's very large construction tents. Or we can print indoors in a factory, print panels, and then when the weather breaks, transport those panels out and assemble it like a very large Lego house.
Mm-hmm. Okay. Yeah. And so then the technology's here. We've overcome some of those challenges. You're wanting to bring it to the market. Why you? Why now?
Well, why now? Because we were Canadian cautious about adoption of the technology when we first decided to do this. And there's a phrase, paralysis by analysis. We wanted to make sure that, does this work? Can this work? Can we bring it to Canada? How do we overcome the temperature? What do we do about sand? Cement, one of the components of concrete, Portland cement, is environmentally horrible. It generates an awful lot of CO2. How do we get around that? What are the alternate chemistries? There was a great deal for us to learn to convince ourselves that we can do this before, and we spent too much time doing it, to be honest. Why now? Because it's beyond time, and housing costs in Canada are an obscenity, and somebody needs to do something about it. So why us? Because nobody else did yet.
Yeah. And so you touched on the housing cost issue. And I know on the website, you guys get into a lot around that in terms of what you're trying to achieve with this corporation, with building more affordable housing for all of us here in Canada. And so can you speak to that a little bit and how important that is as in terms of the core reason for your guys' existence?
Right now in Canada, every home builder in the country is working flat out. They're all building as many houses as they can. And so they should. Prices are high, margins are high. But what that's done is it's created a serious skilled labor shortage. And this skilled labor shortage is worst at the early stages of construction. Cribbers who put up forms for concrete, framers who erect exterior and interior walls and get the building closed in. Those trades are finding a rather grotesque shortage. And what seems to be happening is people my age are aging out and leaving the trade, and young people are not coming into it. They're still coming in as electricians and plumbers and the specialty trades, but the early, I'll call them rough trades, are suffering a serious shortage of labor. So if you can't get the people to start the houses, then it's impossible to finish them. So as all these companies continue to build their houses, they're still falling behind. The demand is higher than the supply. And if Canada comes anywhere close to meeting its target of 400,000 immigrants a year, it's going to get worse rather than better. We need a place to put those people.
Yeah.
Ontario is short 1.2 million houses now. Housing units, I guess we should say. So something has to change. Either our population needs to stop growing, and that can't happen, or we need to build more houses more economically. So by using robotics and specialized materials, we can fill that labor gap at the front end of housing construction. We can get the vertical walls up and ready for close-in very, very quickly. We still need electricians and plumbers and tile setters and all those sorts of things, and HVAC specialists to finish the house, but we can give them a place to start. And that's the real advantage of construction 3D printing.
Well, so and also the speed, I would presume that you can probably build out the house frame like way faster than what the framers or the traditional model would be able to do it, right?
Yeah, there's some pretty serious advantages to the technology. One is it's quick, and as you note, we can erect the vertical walls, interior and exterior, for 1,000 square foot house in less than 2 days.
Yeah.
And that's because the robot doesn't take smoke breaks. It doesn't have to go to sleep at night. Um, we do have to worry about noise bylaws and that sort of thing, but you can get around that usually. And if it means you have to work 12 hours a day for 4 days instead of 24 hours for two, that's okay. It still gets the vertical walls up and the house ready for close in, windows and doors and a roof very, very quickly. One of the other real serious advantages to construction 3D printing is the lack of waste. If you think about how a normal house gets built, large pieces of lumber are brought to the job site. They're cut into smaller pieces of lumber as needed, and the offcuts are tossed into the trash. And there's a laborer who goes around picking up all these offcuts and moving them to the trash, and then it's trucked out to the landfill. And depending on which study you read, somewhere around 10% of all the material taken to a job site ends up in the landfill. And another estimate says 7 tons of waste per house. Now, the cool thing with construction 3D printing is we bring dry ingredients and a garden hose to the job site. The material is mixed in a small mixer at the front end of the printer, and it's delivered exactly where it's needed. And when the building is finished, it stops printing, and there's the functional equivalent of no waste. A couple of 5-gallon buckets of waste slurry as we wash out the machine at the end. The advantage is, of course, we're not paying for material we don't need, and we're not paying for transport to the landfill and landfill fees, and we're not filling up landfills with 7 tons of material per home.
Yeah, it seems like a no-brainer, really. I mean, you are developing these houses faster with less labor in a situation in which we have labor crunches, like you articulated. The waste is lowered. I'd imagine, there's an R value that's inherent in concrete that is maybe not inherent in some of the other materials that traditional houses are built in as well, and probably also strength and longevity of that house and that too, eh?
Well, yeah, you raised some good points. So the walls are typically built very much like a piece of corrugated cardboard on edge, where you have a surface on the inside, a surface on the outside, and a wavy bit in the middle that provides the strength. So our walls would typically be 8, 10, 12 inches thick, but it's only 2 inches on the inside, 2 inches on the outside, and then the wavy corrugation in between. And depending on the climate we're working in, that the spaces in the corrugation can be left blank, left empty. They can be filled with loose fill insulation of varying grades, depending on what's needed for the location. Or in the high north, where extreme cold is a consistent problem, they can be filled with self-expanding polyurethane foam. Now, that's not environmentally the best choice, but it may be the only choice if you need to insulate really well up there. Mm. The house itself, the shell, is a monolithic single piece of concrete. Once you get that warm, it tends to stay warm. So they act as a very large heat sink, a heat mediator. So the cost to heat and cool these places tends to be dramatically lower than a conventional house, unless the conventional house is built to net zero standards or passive house or something like that.
Yeah, that's fascinating. Yeah, lots of advantages to it. Now I'm curious about your background, though, Ed. So, are you a veteran of the construction industry? Then, is that how you got into this?
Yes and no. So, my first job out of high school was actually building mobile homes for a place called Instant Housing up on 16th Avenue here in Calgary. I moved out of that, and I wandered around through the Canadian oil patch because that was a rite of passage back in the 70s. Young men had to work in the patch, and then off into electronics, and then from there into IT, and from there into IT project management. And I spent the last 13 years of my working career, my conventional career, as an international IT project manager for a US company. So I have a broad base of stuff, and I was involved in one early stage startup that eventually made it to a market cap of $600 million. I was their COO.
Oh, wow.
So I have a really broad sort of jack of all trades kind of business education. I fell into this in a really strange way. Well, it sounds strange when I tell it, at least. Our lead designer and the guy who sparked this project, Frank, was a member of the hobby 3D printing community, and he was making plastic things, and every now and then he'd sell one. But because of his connection to that group on social media, he would see the occasional news flash about somebody 3D printing a house in the Netherlands or something like that. And he thought, oh, that's really interesting. And he sort of puttered around staying abreast of the news for a while. And one day he was sitting at a Tim Hortons, that classic Canadian business meeting place, chatting with a friend. He mentioned this technology and how you could build houses with curved walls, and wouldn't that be cool? And the two of them happened to be artists, so they were sketching out some stuff on the back of napkins. And Frank says, I'd really like to do this, but I don't really know how to build a house. And his friend does that typical scene out of a movie, puts a finger in the air and says, I may know a guy.
Yeah.
So she put Frank in touch with David. David has a long history in construction and non-destructive testing and destructive testing and material science and that kind of stuff. And he's a general contractor. So the two of them got together and well, geez, maybe this can work, but I don't know how to build a business. David puts his finger in the air and says, I may know a guy. And that guy was me. Now, it turns out that David and I went to grade 1 together 60 years ago and have kept contact over the years. So I got brought in as the business guy. So we've got a designer, we've got a construction and materials guy, and now we got a business guy. And then a short while after that, we picked up 2 more directors, one of them with Gary, with a real specialty in systems and controls and robotics. And our most recent addition, Kurt, a 30-year military veteran with an expertise in logistics and project planning. So that's how the company came to be. Literally, Tim Hortons and the back of paper napkins.
Yeah, which is great. Like you said, a very Canadian story for sure. And I think there's a lot of businesses that have started up in the exact same situation on the back of a napkin and Tim Hortons. So you have the team then assembled. And at that point, then you guys continue doing the research. Do you have any prototypes or anything like that you have at this point that you're using then to try to fine tune the larger scale technology?
We don't own a concrete printer yet.
Okay.
We need an investor before we can do that. We have, secured the rights to use a concrete printer, and we're involved in an R&D project with an Edmonton group, Green Violin, YEG. They're a not-for-profit affordable housing provider. And we're going to use that printer and some specialty mortar mixes. We're going to build test walls. We've designed a house for them. It's going to be a backyard suite in one of their installations. And if all goes well, and I believe it will, we'll print that house for them June of this year using this printer. We're looking for ways to acquire that printer in a mutually beneficial way. So we honestly expect to be viable, working as early as Q2, but hopefully not later than Q3 of this year.
Yeah, it's really exciting. Now, one of the things that comes to mind is just the challenges around regulations and building codes and so on. Is there anything there that is a challenge to you guys as you move forward with the business?
Yes. The construction industry is well established, and the inspections and rules and standards are well established. They've been developed over more than 100 years, and they're based on the principle, we did this and it worked, so we'll continue to do this. The construction industry is possibly the last major sector to automate, to take advantage of robotics and digital things. So there is a perception in the industry and among the inspectors that this is just too weird. How can we do this and how will you get it inspected? And we're working with the City of Calgary inspectors and permitters to develop a webinar to explain to that sector of the industry how this works, why it's marvelous, and why it's okay to permit it, and why it's okay to inspect it and give your approval. If you think about my analogy with the corrugated cardboard, it's not dramatically different in appearance to a cinder block wall. Mm-hmm. You stack up concrete blocks, they have holes in them. So there's an inside surface, an outside surface, and webs between. And we've been building with cinder block for 60, 80 years. This is just one continuous cinder block instead of a whole bunch. In fact, it's stronger because it doesn't have as many joints. So we're working with that sort of a concept. In addition, every building code in Canada is based on the Canada Building Code. And the Canada Building Code has a section that permits alternative construction and materials, alternative methods and materials. And in there, it says, to shorten it up a lot, if you can prove to us that this is as good as or better than the standard, then you're allowed to use it. Mm-hmm. So if we can prove to them by an engineering report that our printed wall is as strong or stronger than a CMU cinder block wall, then they have no choice but to permit it.
Excellent.
Now, that doesn't mean we won't encounter Joe, who's been inspecting these things for 63 years. And he says, you have to fill that corner with concrete and rebar, or I won't permit it. We'll still run into that. And in those cases, we'll fill the corner and stick some rebar in it for him.
Yeah. Yeah. So I'm just curious, Ed, with the entrepreneurial background that you've had working with other startups and so on, and then your experiences here, my audience oftentimes really likes to hear what the lessons that entrepreneurs have had, so that they can maybe learn from those, or if there's any mistakes, learn from the mistakes along the way as well, so that they themselves don't make them. Is there anything you can share with the audience in terms of your background, lessons and mistakes, and how you've overcome some of those other challenges?
There are two or three things I think that are worth sharing. I've already touched on paralysis by analysis, and it is possible to spend your entire life trying to decide if you should do something. Make your decision early, go for it. I think it's Elon Musk that says, fail early, fail often. If you're pretty sure it's a good idea, that should be good enough to take the next step. And we have slowed our progress because of this, because of excessive caution. Some advice to really early stage startups. If you possibly can, get an accountant involved early. And if possible, get that accountant on your board of directors so you can make them work for free. There is no substitute for having some. Say, I'm not an accountant. I don't like accounting. So our books were a mess for a while. And here we are getting ready to go out into the investment community. And now we're paying somebody to fix the mess that I didn't do because I don't like accounting. So find an accountant that you trust and get them engaged early.
A question that I have for you, just to expand upon that a little bit, is with regard to your business being a very much a socially focused business. It has a huge social mandate to it, but it's yet still a corporation and not a not-for-profit or charity. Is it more difficult or less difficult in your experience thus far in attracting interest, especially from the investment community, as you start to really try to line that piece of the puzzle up?
We're fortunate to be in Alberta. As much as Alberta is very often considered the redneck cousin in Canada, there is a vibrant startup community that's developed in the last 3 or 4 years. There are organizations and associations and grant-giving agencies all over the place here that make Alberta a really good place to start a business. I think that really our lack of progress is literally due to this paralysis by analysis. We have broken out of that shell in recent months, and we're attending webinars and things like this, like your podcast, getting our name out, getting known, aligning our ducks so that if somebody comes along and says, "Hey, I have some money, let's see your books," we can show them something that makes sense. We're doing all the things now that we should have done a year or a year and a half ago. Another piece of advice for startups, and this is especially appropriate for Alberta startups, and that is get yourself into an incubator. Once you have your core team, even if you're not incorporated yet, get yourself into an incubator. This will tell you very, very quickly the things that you don't know and the things that you need to work on and the things that will help you build your business to the point where it is fundable, where it is startable. And there's lots of them. There are pre-accelerators, pre-incubators, and then incubators, and then accelerators after that. And so there is lots of help available for Alberta startups. One of the ones that I was in just very recently actually had 2 Canadian citizens who are resident in Nigeria, and they want to bring Nigerian or African food to Canada. So they were attending these meetings at 3 a.m. their time by Zoom, but they were welcome, right? Because they were Canadian. They were actually Calgary residents who happened to be out of country. So there's lots and lots of help there, and the value is immeasurable. It allows you to focus on things places where you're weak, and it will introduce you to people who can help. Yeah. One more thing before I let you back in, and that is make sure there's someone on your team that is at least moderately comfortable with public speaking. You will need to be doing things like podcasts. You will need to be making presentations and pitches to investors. And a clumsy pitch is at least as bad as no pitch. You need someone who is comfortable talking to people.
Well, those are really great pieces of advice, Ed. I really appreciate you sharing that with the audience. And if anybody wanted to reach out to you to chat more about what you are doing or explore the possibility of investing in 3D PHC, or to potentially be one of the first people to have a 3D printed home in Alberta, how would they do so?
There is a contact page on our website, 3dphc.ca. My email address is emacnab, EMACNAB, at 3dphc.ca. And at risk of doing something foolish, my cell phone number is 403-681-4862.
Awesome. Well, thank you so much for that. And thank you for spending some time with us today to explain 3D printed homes in Alberta, some of the challenges that you guys are facing there, but then also all of the incredible opportunities that this new technology is presenting to, residents here, and the social difference that it's going to make if we can bring down the cost of housing in our expensive cities right now.
Yeah, we can and we will. And thank you so much for this opportunity to talk about 3D PHC. I appreciate it more than you'll know.
Thank you very much, Ed. And there you guys have it, another episode of Amplify Your Business. And if you like this episode and are interested in checking out some of our past episodes, head over to amplifyyourbusiness.ca. And there you'll find our full archive and also an application form if you happen to be an entrepreneur who has an interesting story that you'd like to share with our audience. Just complete that form and we will be in touch. So until the next episode, everybody, enjoy the beautiful weather and also stay safe.